Weld lines are regions where separated melt fronts recombine. The separation occurs due to obstacles such as core pins, geometrical features, multiple injection locations, and/or material jetting. We're typically interested in weld lines, knit lines, or weld surfaces as they're called for two main reasons. The first being product quality concern, such as strength reduction. The second being aesthetics. Weld lines tend to produce visible lines on part surfaces. This discussion will be focused on predicting the strength reduction of a weld line present in a part using a combination of Autodesk Moldflow and Autodesk Helius PFA. Autodesk Moldflow allows visualization of weld lines in two different manners, the first being a 2D representation of a surface formation. This gives users an indication of where weld lines might be visible on the component. The second visualization and representation is the 3D formation and movement of the weld line. This data is used for predicting the strength of a weld line. To show this, we can look at the formation and movement of a weld line. Here is the prediction of the formation of the weld line using Autodesk Moldflow. Note it corresponds to the same locations predicted in the 2D representation. However, after the weld line forms, it then moves to its final location. The final location of each weld line material location is paramount for predicting the strength of the overall component. Autodesk Helius PFA allows users to map data from Moldflow to structural simulation, such as fiber orientations and weld line locations. Here we're showing the weld line mapping from Autodesk Moldflow on the left to structural on the right using Autodesk Helius PFA, as well as using Autodesk Helius PFA to predict the strength reduction of each weld line point. The strength reduction model employed by Autodesk Helius PFA is dependent on the temperature history, the pressure history, and the angle flow front, the flow front meeting angle of each weld line material. On the screen is a comparison of experimental values of a tensile bar without a weld line and a tensile bar with a weld line to those simulated using Autodesk Helius PFA. Note that the prediction with the weld line and Autodesk Helius PFA employs the mathematical model shown on the screen. Using Autodesk Helius PFA to predict the strength reduction of weld lines allows for more accurate prediction of the strength of fiber reinforced parts and unfilled parts. Of weld lines allows for